Let us integrate 4x e to the 4x dx. Now, we're going to use integration by parts because we see we have two functions here in x that multiply each other. Here, we can consider this. I was going to think about putting the 4 behind the integral sign, but we don't have to do that as yet. Let's look at the integration by parts formula. It says the integral of u dv equals u v minus the integral of v du. All right. Now, which one are we going to use to represent u? Here, look at this. If you choose u for 4x, you're going to differentiate to get the u, and you're going to get just 4. So we use that. If you choose u for e to the 4x, when you differentiate e to the 4x, you're going to get 4e to the 4x. And that will not simplify the function as you go along. So we're going to have u being equal to 4x dv is equal to e to the 4x. Now, du will be 4. When you differentiate 4x, you get 4. We want to find out what is v. In order to go from dv to v, you have to integrate. All right? So, let me have that. This is du equal 4 dx. Since we have a du and it's being integrated with respect to x, we have 4 dx. We have dv equal e to the 4x dx, right? V now, in this case, you have to integrate e to the 4x. If you've been using or been practicing integration of e to the constant times x regularly, you'd know this would be e to the 4x over 4. Let's look just a minute or so and look at it. You have integral of e to the ax, right, dx. If you use substitution and let u be equal to ax, then du by dx would be a. So therefore dx would be du over a. So the integral would be the integral of e to the u. Remember, u would be this in the same position as ax, e to the u, times dx. But dx is the same dx here, which is du over a, where a is a constant. Alright? So it's du over a. So that now would be 1 over a integral of e to the u du. And when you integrate e to the u, you get e to the u. So it's 1 over a e to the u plus c. But what was u again? U was ax. So, therefore, the integral of e to the ax, just a reminder here, the integral of e to the ax is equal to, this would be e to the u, which is e to the ax divided by a. plus c. Remember that? So you divide by this. You divide by the derivative of what you have in the power. Alright? So back to what we were doing now. In this case, a would be represented by a 4. So the integral of e to the 4x would be e to the 4x over 4. Now what do you have here? It's the integral of u, which is 4x, dv, which is e to the 4x dx, is equal to u, which is 4x, times v, which is e to the 4x over 4, minus the integral of v, which is e to the 4x over 4, times du. Let me rewrite that. V is in blue. E to the 4x over 4 times du. What is du? Du is 4 times 4. Alright? So, what do we have here? Let me just erase some part of what we did before when we were integrating e to the 4x or e to the ax. This integral is equal to 4x e to the 4x over 4 minus 4 in the 4 1, 4 in the 4 1. There's the integral of e to the 4x dx. We're integrating with respect to x, so we have a dx there. So, what we have now is that this is equal to 4 will cancel 4, x e to the 4x minus this now will become e to the 4x over 4 plus c. So that is what we have as our solution. What we can do also, if we want, we could factorize and get e to the 4x outside the bracket. So we'll have x minus a quarter plus c. X minus a quarter inside the bracket plus the constant of integration.